In this lesson, we're going to take a look at cross products. Cross products is the idea of producing a vector that's perpendicular to two other vectors. This can only happen in R3, so everything we deal with today will be R3. So if we take an idea of two vectors that are both in the xy plane that are not collinear, they point in different directions, we can produce a vector that would be perpendicular to both of those at the same time if we think of a vector that's parallel to the z-axis, a vertical vector, if you will. So for example, we have the two on the screen here. We have the one that goes up and the one that goes down, but it could be other ones. It could be one that's over here. It could be perpendicular to B and perpendicular to A. It could be over here, perpendicular to B, perpendicular to A. And lots of vectors. In fact, an infinite vector. And all of those will be perpendicular to both A and B at the same time. And our objective today is to actually produce one of those vectors. And we can do that using the cross product. The cross product can be found by a little bit of algebraic operations. We'll get to that in a second. Just a little bit of notation first. Cross product is signified by this cross symbol. It does not mean multiplying. You might recall that multiplying is actually called the dot product when we deal with vectors. But the cross symbol means cross product, and it actually produces a vector in itself. So it's kind of both a direction and a magnitude. You also might notice that A cross B and B cross A actually point in different directions, and that's kind of a key that the order of things does matter. Because there are these infinite number of vectors that we can produce, we have to agree on the one vector we want to produce. And we can do that by creating a formula for this vector. The formula for the cross product is found out by using the components of each of the two original vectors and using them in this combination. So the x component is found by a2b3 minus a3b2, where a's are the components of the a vector and b's are the components of the b vector. We can do the y's, and that would be right here. This would be your y part, and this would be your z part. Now, I don't expect you to memorize the formula. By no means. There's a process we can use to help us remember this formula. Actually, there's two processes, and I'll show you both, and we can decide which one you want to use and what makes more sense to you. Now, remember, order is important, so whatever order things are listed in is the order we're going to do our cross product in. So let's take a look at the first one, and we'll use the crisscross method, and we'll talk about how that one works. So A cross B can be found using the crisscross method by making a list of the components of each vector starting at the y component. So for A, that would be 3, 4, negative 2, and then back to 3 again. For B, it would be negative 2, 4, 1, and negative 2 again. And the way the crisscross method works is we're going to multiply diagonally and then subtract on the way back. So for us, in this example, 3 times 4 would make 12, minus 4 times negative 2 is negative 8. And there's your x component. So your y component, you do next to that, minus that. So we do 4 minus negative 8 again. And to the z component, we do these two minus these two. So 4 minus 3. And if you do the math here, we end up with a vector 20, 12, and 1. And that's our crisscross method. Now, some people like that, some people don't. So I'll show you a second method called the cover-up method. If we're doing the cover-up method, and we do the same two vectors, we're just going to list them horizontally this time. So negative 2, 3, and 4, and 1, negative 2, and 4. And now when we do A cross B, we're going to cover up the x parts and do the crisscross with the remaining parts. So notice it's A2 and B3, and then minus B2, A3. Okay, so in our case, what would that look like? It would be, if you cover up the x's, you get 12 minus negative 8. Cover up the y's, cover up the middle two, we're going to get 8 minus 4. Now there's one trick here. So it's negative 8. One trick here when you do this is the y component is always the opposite sign. Okay. Then we do the z component, cover up the z's, so we'll get 4 minus 3. What do we get? Well, 12 minus negative 8 is 20. Negative 8 minus 4 is negative 12. We take the opposite sign, so positive 12. And 4 minus 3 makes 1. And then we found ourselves a cross product. So both ways work. And these are pretty quick ways, really. We actually did this question a couple of days ago when we did the dot product. We had to find a vector that's perpendicular to two other vectors, and we had to use a process where we created ourselves a new vector. And it was actually a fairly lengthy process. You might recall we had to do a dot n had to come out to 0 because they're perpendicular, comes out to 0. And b dot n comes out to 0. And we ended up with 3 equations, which we had to solve simultaneously, creating a parametric equation. You might remember that the parametric equation was t, and if you're not, just look it up in your notes. 5/3, 1, and 1/12. And we said, well, that's what happens if we pick a nice value for t, for instance, 12. We created the vector 12 times 5/3 times 1 times 1/12, which came out to 20, 12, and 1. But there was a whole page of work before that. By doing the cross product, we found the exact same thing, just doing it a whole lot faster. Okay. Now, because we're creating vectors and it's kind of hard to visualize at times, we sometimes want to be able to check our answer. And a good way of checking your answer is by referring back to that dot product idea. We know we've created a vector. Think about our 2 planes here. That's perpendicular to that. It goes up like this. Well, if it's perpendicular to both those at the same time, then the dot product of either of those 2 vectors and the new one has to come out to 0. So a way of checking is take your cross product and dot it with one of your original. So a cross b with a, or a cross b with b, and it should come out to 0 if you did it right. So for the previous example, a cross b, if I were to dot that with a, I'd get 20, 12, and 1 dotted with, our numbers were negative 2, 3, 4, negative 2, 3, 4. If I dot those, I get negative 40, 36, and 4. If we add that all together, it comes out to 0. So sure enough, the cross product we produce, that new vector, is indeed perpendicular to A. And we could test with B too. It kind of code the same thing. Okay, so here's a couple for you to try. Okay, V cross U. Okay, using the crisscross method. Negative 3, 5, 2, negative 3, negative 1, 4, 0, negative 1. We would get negative 12 minus negative 5, so plus 5. We would get 0 minus 8. We would get negative 2 minus 0. In other words, negative 5, negative 8, negative 2. If we want to do a check, let's take our cross product and dot it with u just for fun. What do you got? Negative 5 times 0 is 0. Negative 8 times negative 1 is 8. Negative 2 times 4 is negative 8. I got the right answer. Okay, if we try the next one, let's do m cross n. And we'll use the cover-up method this time. So 2, negative 1, 3, 3, negative 1, 2. And if we do the, get rid of the x components first, negative 2 plus 3. I want the opposite of 4 minus 9. And then I want negative 2 plus 3. We get 1. We get negative 5 in the bracket, so positive 5 and 1. And if we check it, this is just our check. We would get, let's start with m just to see what happens. 2 minus 10, oops, sorry, not minus 10, minus 5. 2 minus 5 plus 3. We get 0. So we know we got the right answer. It's a good way of checking. Yeah, so a thinking question for you. I told you, I showed you in the picture that A cross B and B cross A were the same vectors, collinear vectors, but they point in the opposite directions. How could we prove that? How could we show that? Well, the easiest way is to pick something with some numbers. So let's pick a vector A. Just pick some nice easy numbers here, 3. And we'll try B, and what's some other easy numbers? We can do 0, 1, and -1. As long as these two vectors are not collinear, right? And if we try B cross A would be, you might as well do the crisscross method since I left them above each other, right? We got -2 minus 3. We've got -1 minus 0, but we want the opposite sign. And we've got 1 minus 0, which gives us -5, 1, and 1. And then if we want to do A cross B, actually, you know what? I just did A cross B, right? Because I was upside down. This is A cross B, sorry. Get rid of that. That's A cross B. Now we're going to do B cross A. So let's erase this. B cross A. B cross A, which means I got to put the B one on the top and the A one on the bottom. 1, 2, 3. Okay, what do we get for B cross A? We're going to get 1 times 3 is 3, minus -2 is +2. Go with the negative of 0 plus 1. We want 0 minus 1. What do we get? 5, -1, -1. And sure enough, A cross B is the negative of B cross A. They have the same values, they're just opposite signs. Collinear, opposite directions. Okay, and there's a low proof. Now there's some properties of the cross product that help us do some things that we can use later on. We've already proven that order matters, we just did that, right? We can also prove that you can distribute things. You can add vectors together first and then do the cross product, or you can do the cross product first and then add them together. You can multiply by a scalar, or you can multiply in by a scalar and then do a cross product. And one that's kind of obvious but hard to prove is that collinear vectors create a zero vector. Well, collinear vectors are on top of each other. So if you're producing something that's perpendicular to both, you can't really do that, right? It's not going to have any direction left over, because when you do your cross product, you're going to end up with 0, 0, 0. There's nothing left over, okay? Because all the values are multiples of each other. So we're going to prove one. So I told you back here you can distribute. Let's try that. Let's prove that if we can. So I want to suggest that P cross Q plus R is the same as P cross Q and P cross R. So let's try it. Let's do P cross Q plus R. So the first thing we need to do is Q plus R. So simple addition. You can add them together. Q plus R is 0, 3, and 7. So if I want to do P times P cross, Q plus R, if I put them on top of each other, 1, -2, and 4, 0, 3, 7, we'll get -14 minus 12. We'll get the negative of 7 minus 0, and we'll get 3 minus 0. Or in other words, -26, -7, and 3. Okay, so the left-hand side would equal. If we do the right-hand side, P cross Q, we have 1, -2, and 4, and 1, 2, and 7. We'll get -14 minus 8. We'll get 7 plus 2. And we'll get 2 plus 2. Oh, sorry, you know what? 7 plus 4 in the middle here. Sorry, there's a 4 there. Okay, so we'll get -22, -11, and 4. If we do the same thing, but we're now doing P cross R, P cross R is 1, negative 2, and 4. 1, 1, 0. We will get 0 minus 4. We'll get the opposite of 0 plus 4. And then we'll get 1 minus 2, which is negative 4, negative 4, and negative 1. Actually, I have a little mistake just back here for a second. This is 7 minus 4. Looking ahead, I already know that that wasn't going to work itself out there, so I had to fix that there. Okay, so this should be a 7 minus 4, and which would be negative 3. So I got that. Okay, so then we take our P cross Q. We want to add that with our P cross R. We can literally just add those together, right? What do we get? Negative 26, negative 7, and 3. And we've proven that that distributive property works.